On June 2nd and 3rd, 2011, the Center for Design and Geopolitics held its first annual conference in La Jolla at CalIT2, the California Institute of Telecommunications and Information Technology, on the campus of the University of California at San Diego. Our next speaker is Charlie Kennel, a true expert and visionary in questions of the generation, distribution, socialization, and visualization of data at this scale. Charlie was the 9th director of the Scripps Institute of Oceanography, which, as many of you know, is one of the part of the UCSD institution, one of the key centers globally for the development of core climate science. Charlie was the former associate administrator at NASA. He was the director of NASA's Mission to Planet Earth, a program during the Clinton years to perform a comprehensive survey and observation of Earth. He was a member of the NASA Advisory Council. 2005, Charlie founded the UCSD Environment and Sustainability Initiative, which has become the Sustainability Solutions Institute, which we still enjoy. He's a member of the National Academy of Sciences, the American Academy of Arts and Sciences, the American Philosophical Society, the International Academy of Astronautics. Kennel served on many national and international boards and committees, most recently the NRC's Beyond Einstein Program Assessment Committee, and again, he was a member of the NASA's Advisory Council as well. So it's my pleasure to welcome Charlie Kennel.
All the CV shows is that if you live long enough, you get to have a long list, especially if you work at the University of California, where they require you to count absolutely everything, every breath that you take that has professional significance. So my talk won't be as panoramic as Larry's, but I will talk about, I think, how the knowledge that, in particular, climate scientists are generating actually affects governance, not only for climate science, but will eventually affect governance in general. And as part of that, I will be talking and focusing mostly on the way that scientists have in the past assessed climate change in order to communicate understanding to decision makers, how the problem has gotten out of hand, and how, as a result, the assessment process will need to change, and it hasn't done that yet. I have no slides. You'll think I'm lazy. It's partly true. But the deeper reason is that the work I'm presenting today is from a paper that Ram Ramanathan, and David Victor and I are just finishing, and I didn't have any slides prepared for it. Let me start by giving a brief history of our consciousness of climate change. The possibility was first pointed out in the 1890s by Gustav Arrhenius in Sweden, but the imminence of it became clear when Charles David Keeling here at Scripps started his now famous collection of data documenting the increase of carbon dioxide in the atmosphere. That started in 1957. By 1960, he was convinced that the rise that he was seeing was due to the CO2 that our industrial civilization was putting into the atmosphere. By 1979, the rest of the world was convinced of that in the scientific world, and there was a famous Academy panel in 1979 that first announced the policy significance to the general policy community of the rise of carbon dioxide, the imminence of global warming. They predicted that it would become manifest and grow above the level of climate fluctuations by the year 2000, which it did. So we knew the basics even in 1979. There was one significant event in the history of climate that occurred before that. That was 1974, when Scripps' former director, my predecessor, Roger Revelle, gave a lecture that Al Gore listened to. That had significance for the future. But in the 1980s, it became clear that two things became clear: that you really need to develop a whole new branch of science, which he eventually called Earth System Science, whose goal was not to document the deep geological past, but to predict the future, next 100 years, basically. And the other part of it was that we understood the climate problem was developing at a rate that would strain every institution in society, and that in terms of science's contribution to adapting or trying to cure it, we had to accelerate the usual process by which scientific information is conveyed to decision makers. In the past, the usual process was the scientists with new ideas waited till their enemies died off. People wrote a review article, and about 10 years later, the policymakers considered it to be established enough that they could use it. The climate clock was ticking, and you had to accelerate that process. So at that time, in 1988, the UN, under the auspices of the UN Environmental Program and the World Meteorological Organization, created the Intergovernmental Panel on Climate Change, which is basically the world's largest, most continuous review article of any subject in science that has ever been done. And its purpose was to take emerging research and vet it as quickly as possible against all the competing views, smooth them out, reach a consensus, compare it with data, and convey what you knew to the decision makers. Now, the IPCC then was structured as a global process, in part because carbon dioxide has such a long lifetime that it's globally distributed, and it was clear that it affected everybody on the Earth. And so it was structured, the IPCC was structured by the basic properties of carbon dioxide. And as it turned out, it then, in the fullness of time, created what we hoped would be the negotiations leading to a governance structure. So in 1995, the Conference of the Parties, from the parties to the UN Convention on Climate Change, was founded, and every year now a global set of negotiations go forward, trying to reach a consensus agreement on methods for limiting the emissions primarily of carbon dioxide into the atmosphere. And so what happened was that the assessment process and the negotiation process, the precursor to governance regimes, co-evolved. They were central, top-down, and they focused on the carbon problem. And the carbon problem was, for the reasons that Larry pointed out, also the most ethically prepossessing of the problems. It was because every carbon molecule that I caused to be put into the atmosphere of every 150 will be around in 100 years from now, and as Larry pointed out, 25 in the thousands of years. And more than that, the energy that we're putting into the oceans won't be released for centuries. So we are causing climate warming over 1,000 years with what we're doing now, and we're causing it for everyone on Earth now, and we're causing it for every human being on the Earth in the future. And that is the central ethical issue. And this has then prompted a tremendous conflict between ethical concerns and economic concerns, which has yet to play out and is probably a cultural transformation as large as, let's say, slavery. So, but to go back then, I'm not going to trash the IPCC, because the whole process of integrated assessment for environmental and other issues is probably the most important social technology devoted to science in the 20th century. But over the 20 years that this process is going on, you have noticed that the negotiations have failed to reach a global agreement, a consensus agreement. they're not structured right. There's too many, 193 nations at Cancun. And some of them, like Russia, actually believe they might benefit from climate change. A lot of people are kind of neutral about the whole issue, and there are a few advocates. Even the enthusiastic countries, Europe and Japan, although they have taken strong steps to reduce their carbon emissions, have still seen their net emissions rise. And as Larry pointed out, there's China. So it's now clear that the negotiations, you can't expect them as currently structured to make any progress that is rapid and decisive. Even if they did, even if tomorrow there was a global consensus on the regulatory or other economic incentive regime, it would take you about 40 years to, and there have been many energy studies that now say that, it would take you 30 or 40 years to take today's innovations in energy technology, which are at the beginning phase, and see them spread globally around the world so that they have a material effect on global emissions. Even so, it will be very difficult to carry out that regime because the most rapidly developing countries, seeing the greatest increase in their welfare, are primarily dependent on coal. So, and 50 years from now, let us say, we have succeeded in reducing emissions. The California goal is 80% below 1990 by 2050. Even after we have done that, because of the long lifetime of carbon in the atmosphere, it will be at least another 50 years before we see material reductions in the rate of growth of temperature, largely because of the sins of the past, with all the energy that is now stored in the ocean. So this means then that no matter what we do, as Larry has pointed out, we're in for major climate change. Now, and it's undoubtedly, I think, over the long term going to require innovations throughout society and not just simply in the energy sector. At the same time, however, there is the question, what can we do? Let us just postulate that over the next 30 or 40 years, we are not going to be able to solve the carbon problem, even if we go flat out. Are there things that we can do in the intervening time that will at least take the edge off climate change and give us a little bit more time for people like you to redesign our cities and not break the world financial system? The problem is complicated by the fact that we have not realized in general, in the public, that in fact we have thus far been protected from global warming by another thing that we are doing, which is emitting sulfate particle pollution into the upper atmosphere. And the sulfates tend to counteract the global warming. They reflect visible light back into space, and the greenhouse gases contain infrared. And at the surface, there's this competition between warming by greenhouse gases and cooling by the sulfate aerosols in the atmosphere. And in fact, as it turns out, if you looked at our present greenhouse gas burden, and if there were no air pollution, we should have warmed relative to pre-industrial time by 2.4 degrees, whereas what we have realized of that warming is 0.75 degrees. So the air pollution, another one of our environmental sins, is protecting us from the worst of the global warming. We've only received 1/3 of what we might get in the runout. Now, we know this in a funny way because in the 1940s through 1970s, the global temperature remained relatively constant, while CO2 went up. And then suddenly in the 1980s, the global temperature went up when CO2 didn't change its behavior. It just grew at the same old rate. And the denialists had a point there the temperature curve and the CO2 curve did not follow. Well, now we understand why that happened. The rapidly growing economies in America, North America, and Europe were polluting. We cleaned up our act beginning around 1975 or so. And as soon as we did that, the global temperature went up. Remember that pollution, though locally generated, the particles are in the intermediate atmosphere carried around the hemisphere by prevailing winds, so they affect everybody. Now, and we also know that this is true because now measurements of brightness, the pollution reduces the brightness at the surface of the Earth, and the measurements of brightness correspond to the measurements of the temperature. So it's air pollution that has caused us to avoid the worst of the warming that we already have created. Now, who is the biggest air polluter in the world? 2 countries, China and India. And our experience, and it's almost intolerable, you cannot expect, it's not a sustainable solution for any society to tolerate air pollution when it's causing so much public health problems and so much diminution of agricultural productivity. It's measurable in Southeast Asia. So they are going to cure their air pollution. Our experience has been in London and Los Angeles and Mexico City and Sao Paulo and other places that once you get down to it, you can do it in about 25 years. So that over the next 30 or 40 years, we're going to have to cope with the unmasking, the realization of more of the potential warming that we've already bought than because of this, and no person can ethically oppose your cleaning up of air pollution. So what then can we do to take the edge off this double whammy, our inability to cope with carbon in the near term, and it's a fundamental one based in the lifetime of carbon, and the fact that that China will eventually deal with its air pollution problem? Well, there are a couple of other levers on the climate system that people and the experts know about, but have not reached policy prominence. The second biggest contributor to global warming is methane. It's 23 times more potent as a greenhouse gas than CO2. It's got smaller concentrations, but it's still responsible for about 17 or 18% of the warming potential that we currently have. It's at the highest level we've seen in 600,000 years, and 70% of it is put into the atmosphere now by human activities. So you can slow the rate, if you will, of warming by dealing with methane. There's a whole collection of gases that we've put into the atmosphere to replace the chlorofluorocarbons, which are destroying ozone. These two are greenhouse gases. And if we continue to apply the Montreal Protocol, we can probably phase those gases out. So our best hope for, our best hope then for making it less severe and buying more time over the next couple of generations then is to go flat out with carbon technology as best you can, but not expect a result that's material during the next 30 or 40 years, and then take the edge off climate change by dealing with the other greenhouse gases and by being very careful in the way you reduce air pollution. There's another component to air pollution, black carbon, which is warming, and you have to match black carbon reductions with sulfate reductions. And that is a very delicate matter, and Ramanathan now has done a computation that suggests if we do all of those things and we limit our carbon to 415 parts per million at 2050, which is only 10% above where we are now, then maybe we can avoid dangerous anthropological interference in the climate. And by that, you would mean the causing of major geophysical events, of which the first one, the melting of the Arctic sea ice, is already in progress, as is the melting of the Himalayan snows. But that's just a scientific plausibility argument. It doesn't mean that it's socially possible. At the same time, though, what you need to do then is to defocus and distribute the assessment process. And the reason is that the sources and distributions and key decisions that lie behind the reduction of methane, their agricultural and other decisions, and the reductions of the fluorocarbon, and the dealing with the climate air pollution nexus, all of those decisions are made primarily locally. And the reasons that the decision makers will have the secondary reasons why, which will actually be the main ones that move them, will all be locally generated. And now, on the other hand, the IPCC is a central global assessment that is designed around carbon and is designed around global climate models, which cannot resolve regional concerns yet. So we need a whole new enrichment of the assessment regime that takes into account the local nature of the sources of greenhouse warming that we can deal with in the next 20 years. And in addition, as Larry has pointed out, almost every decision that is made about adaptation will be local. And so it is there then that we enrich the IPCC process and we turn it from a book that is published every 7 years to an always-on information system that provides decision-ready knowledge for the decision makers.